Hello students, and welcome back to part 2 of lesson 4. As we continue working with the powers of a quotient property, we will continue to give the exponent to both the numerator and the denominator. So in our numerator we have 3x to the negative 2 power over y squared to the negative 2 power. Now we have simplified the power of a quotient property, but we will see other properties still here that leave this expression unsimplified. In the numerator, we have the power of a product, so we need to give the power to each factor in the product. So our numerator now says 3 to the negative 2, x to the negative 2, giving that power to each factor in the product. In the denominator, we have y squared to the negative 2 power. This is the power of a power property, which says we need to multiply the exponents. So we have y squared to the negative 2 power, which is y to the negative 4th power. Now, if you look, we have simplified two multiplicative properties, but we now have negative exponents, which we need to move in order to generate positive exponents. Since the 3 has a negative exponent of negative 2, we'll move it to the denominator to become 3 squared. Since x has a negative exponent of negative 2, we'll move it to the denominator to become x squared. The y has a negative 4 exponent, so we'll move it to the numerator, since it was in the denominator, to become y to the 4th. Now we have no zero exponents, no negative exponents, no multiplicative properties, and no division properties, and it is simplified. Now let's do 3/4 to the negative 1 power times 2x over 3y to the negative 2 power. Take this problem one step at a time. Let's begin with the one on the left. We have the power of a quotient, so we need to give the power to both the numerator and the denominator. So we get 3 to the negative 1 over 4 to the negative 1. Now, as we continue, we don't need the parentheses around this, but we do need to remember that these two amounts are multiplied by each other because they're touching. So we have multiply. Now we have 2x over 3y to the negative 2 power. So we again have the powers of a quotient, give the negative exponent to both the numerator and the denominator. When we do that, we get 2x, all of which is to the negative 2 power, over 3y to the negative 2 power. Now we've simplified the power of a quotient property, but we now see multiplicative properties here. In both the numerator and the denominator, we have the power of a product. So we need to give this power to both factors in the product. When we do so, we get 2 to the negative 2, x to the negative 2, over 3 to the negative 2, y to the negative 2. Here, we can bring this along, or we could simplify it now. We'll just wait though. Over 4 to the negative 1. Now, if you look, we have negative exponents with every factor. That means we're going to have to move them in order to make them positive factors. The 3 to the negative 1 is going to have to go to the denominator to become 3 to the 1, or just 3. The 4 to the negative 1 is going to have to go to the numerator and become 4. 2 to the negative 2 is going to have to go to the denominator to become 2 squared. It's a times symbol. We need something in there to show that it's not 32, it's 3 times 2 squared. The 3 to the negative 2 is going to have to go to the numerator to become 3 squared. X to the negative 2 is going to have to go to the denominator to become x squared. And y to the negative 2 is going to have to go to the numerator to become y squared. Now we have one more property here. We have the same base in a quotient. We know that a to the m divided by a to the n is a to the m minus n, so we can subtract the exponents. 3 has an exponent of 1, so 3 squared divided by 3 to the first is 3. So we have 4 times 3y squared over 2 squared x squared. Now you could leave this like this, but you may notice that 2 squared is the same as 4. And in that case, we do have the same base, 4 to the first and 4 to the first. 4 divided by 4 makes 1. So our most simplified expression is 3y squared over x squared. If you would have left it like this, I would have accepted your answer. In this example, we again have the power of a quotient property. Give our exponent to both the numerator and the denominator. We get 4 to the negative third power over 3 squared to the negative third power. Now, if you look here, we have the powers of powers property, which says a to the m to the n power is a to the m times n. So this is really 3 to the negative 6 power. Bring the 4 to the negative 3 along. Now we have negative exponents, so we need to move them to become positive exponents. So we'll move the 4 to the negative 3 to the bottom and to become 4 to the third. And move 3 to the negative 6 to the numerator and become 3 to the sixth. That is our simplified expression. Let's try 2 more examples. Again, we have the power of a quotient property, so we need to give the power to both the numerator and the denominator. In this case, the numerator and the denominator is made of more than one factor, so we need to use parentheses. So we have ab to the fifth, all of which is to the fourth power, over c squared d squared, all of which is to the fourth power. Now, if you look, we have the power of a product. There are 2 factors inside the parentheses, so we need to give each exponent to each factor. So we get a to the fourth, b to the fifth to the fourth power, over c squared to the fourth power times d squared to the fourth power. Now, we see powers of powers property in 3 different places, so we need to multiply those exponents. So we have a to the fourth, b to the 20th, because 5 times 4 is 20, c to the 8th, d to the 8th. And that is our simplified expression. No negative exponents, no zero exponents, and no 2 bases are the same. If you want to, you can pause the video and try this one on your own, and then watch it with us to see if you get it correct. So we have the power of a quotient. We need to give the power to the numerator and the denominator. So we have 2a to the fourth power, to the negative fourth power, over b squared c cubed, all to the negative fourth power. Now we have the power of a product, so we need to give the exponent to each part, each factor inside. So we have 2 to the negative 4, a to the negative 4, over b squared to the negative 4, c cubed to the negative 4. We now see powers of powers, so we have 2 to the negative 4, a to the negative 4, over b squared to the negative 4, which would be b to the negative 8, c cubed to the negative 4th, which would be c to the negative 12. Now we see that we have negative exponents that need moved to become positive exponents. So 2 to the negative 4 will move to the denominator to become 2 to the 4th, a to the negative fourth will become a to the fourth in the denominator, b to the negative 8 will be b to the 8th in the numerator, and c to the negative 12th will be c to the 12th in the numerator. And here's our simplified expression. So to summarize the rules that we've learned the quotients of powers property. If you're dividing two exponents with the same base, then you can subtract their exponents. If you have a power of a quotient, you can give that power to both the numerator and the denominator.